questions 21 to 25 on the 2003 grade 11 Fermat math contest. A sequence of numbers has 6 as its first term, and every term after the first is defined as follows. If a term t is even, the next term in the sequence is 1/2 t. If a term s is odd, the next term is 3s plus 1. Thus, the first 4 terms in this sequence are 6, 3, 10, and 5. The 100th term is. So look at the previous. That should be the motto for this question. So here we go. Let's list the terms. Let's see. We can list the first 20 and let's see if we see any kind of pattern. So let's start. The first term they tell you is a 6. The next term they tell you is a 3, then 10, and then 5. But let's actually start understanding how did they get these terms. Okay, so I want to figure out what is the 5th term. How do I do that? Well, look at the previous. That's the motto, right? The previous term was 5. Now, is that 5 even or odd? 5 is odd. If a term s is odd, the next term is 3s plus 1. This you can treat as s, so therefore 3 times s plus 1 is 15 plus 1, which is 16. So that is a 16. Okay? So next, the 6th term, look at the previous. It was 16. Is 16 odd or even? It's even. If a term t is even, the next term is 1/2 t. So 16 being even, the next term would be half of that, which is 16 divided by 2, which is 8. All right, so I hope you get the hang of that. Let's find the 7th term. Look at the previous. Previous term was 8. Is 8 odd or even? It's even. So we use this rule. The next term will be that term divided by 2. So since the term is 8, divided by 2, we get 4. Let's go to term number 8. Look at the previous. That's 4. Is 4 odd or even? It's even, and therefore the next term in the sequence will be that term divided by 2. So that means that is 2. 9th term. Look at the previous. Was 2. Is 2 odd or even? It's even, and therefore the next term will be that term divided by 2. So you got a 1 there. 10th term. Look at the previous. Is it odd or even? This term is 1, therefore it's odd this time. So we go to our rule here. The next term would be 3s plus 1. S in this case is 1, so 3 times s plus 1 is 4. All right? And then you just keep going like that, exact same way. And the 11th term would be 2. 12th term would be 1. 13th term would be 4. And then 2, and then 1. And then 4, and then 2, and then 1, and so on. So I hope you see a pattern here. Basically, we got to a point where 421 keeps repeating itself. Ongoing. Sort of gets stuck in that kind of a pattern. So that's good. That means you can look at this in any way you want, but the way I look at it is that every time you see it's a multiple of 3, the term number, our term is a 1. Okay? So you can just keep going like that all the way till 100, 97, 98, 99, 100. Anytime the term number is a multiple of 3, the term will be a 1. So basically, those terms will be 421. And then we get to the 100th one. Since the pattern 421 keeps repeating, it'll be 421 like that for the 101 and 102. So they want the 100th term, and therefore the 100th term is 4. So number 21, the answer is D. Pentagon ABCDE is such that all 5 diagonals AC, BD, CE, DA, and EB lie entirely within the pentagon. If the area of each of these triangles, ABC, BCD, CDE, DEA, and AAB is equal to 1, the area of the entire pentagon is closest to. Okay, so we definitely need a diagram. So here is a pentagon. And the first thing I want to do is concentrate on one of these triangles that they are referring to. So let's label this first. So we've got A here, B, C, D, and E. And let's draw in one of these triangles. Let's concentrate on this one right here. So this triangle is basically EAB, this guy right there. Triangle EAB. And they've told us that if you draw these kinds of triangles, all of them will have an area of 1, equal to 1. Okay? That's going to be very helpful. So this is obviously a triangle that can be calculated as 1/2 base times height in terms of its area. And they tell you that area is equal to 1. So 1 is equal to 1/2 base times height. All right. Let's label some bases and heights. So I'll draw, first of all, a perpendicular to make that represent the height. So that'll be my H. And then I'll call this B and B like that. So therefore, based on what I labeled, I've got 1/2 base. My base, I've called it 2B, just because that perpendicular cuts EB in half. And then H I've just called H. So that means this is just BH, like that. This is B and that's H. Okay. Now, at this point, this is a right angle, and we need to start using a little bit of trigonometry. What is this angle in here? If we knew that, it would be very helpful to us. Well, what is this angle? That we know. How do we know? Because the sum of all the interior angles in a pentagon add up to 540. And therefore, each of those interior angles would be 540 divided by, how many are there? There's 5. And therefore, each of those is 108. So this guy in here, this blue, is 108. So this in here is half of that, since that line cuts it in half. So 108 divided by 2 is 54. That angle is 54. Okay? And therefore, this angle is 36. Simple. Based on the sum of the angles of a triangle is 180. So now we're going to use a little bit of trigonometry to compare this angle, this height, and this base. The sine of 36, and you can use any angle you want, I just decided to use 36, is going to be opposite over hypotenuse, correct? And hypotenuse in this case is AB, right there. And I'll just call it X instead of having to write AB every time. Okay? And therefore, we can write this in terms of H, X sine 36. And in a very similar way, I'll use cos. Cos of 36 will be B this time, this guy right here, over X. And B, therefore, is X cos 36. All right? So now I go back to this formula right here, which I created earlier, and use my two trigonometry equations. So 1 is equal to BH. So that means that 1 is equal to B, which is x cos 36, times H, which is x sine 36. All right, let's move this up. Now this basically becomes, the x is combined to become x squared, and this becomes cos 36 and sine 36, which have numerical values, of course. And then x squared becomes 1 over cos 36 times sine 36, like that. And if you do the math, you'll get that this is 2.1029. Take the square root, and you'll get 1.4501 to 4 decimal places. All right? So you've got yourself the value for x. And remember, x was one of the sides. So now we can pretty much proceed with calculating the area of the Pentagon, which is what they want us to do. The area of the Pentagon. So here's my fresh Pentagon again. I didn't want to get the previous diagram messy. So now what I'm going to do is attempt to figure out the area of this Pentagon. And the best way to do that is to just draw the center and then draw lines to each of the vertices. So like this, like that, that vertice, and that vertice. Okay? I hope you can see, even though this is not perfect, that I just cut it into 1, 2, 3, 4, 5 equal triangles. So if I can find the area of one of these triangles, I can then multiply by 5, and I will get the area of the Pentagon. So area of Pentagon will basically be 5 times the area of one of these triangles, which will be 1/2 base times height. Okay, so now let's concentrate on getting the base and the height of one of these triangles. So the first thing, of course, I've got to draw a perpendicular. That will represent my height. And this is, of course, the base. The base we previously labeled as x. And not only did we label it, we also found the value. Right? That's great. We will definitely need to use that. If we can somehow get this height in terms of x, we're set. So how do we do that? We previously found out, or figured out, that each interior angle is 108. So that means that this guy in here, this angle, is 108. Now this orange line cuts that in half, so that basically means that this is 54 in there. This is a right angle, and this is 36. Very similar to what we did earlier. And therefore, we can now proceed again with trigonometry. And this time I will use tangent, tan. The tan of this angle, 54, is equal to h, right, opposite over adjacent. Now what's adjacent? Be careful here. Adjacent is just from there to there. That's not x, it's x over 2. Okay? Just make sure you don't make that mistake. So that means h is equal to x over 2 tan of 54. And both of these we know x is 1.45 right there, 1.45 over 2, and the tan of 54 is just some number. And if you do the calculation, you'll find that h is equal to about 0.9979. Try to be as accurate as possible, because in the end, our answer choices are very similar, actually. You see how similar they are? So I've got to be as accurate as possible, otherwise I might end up with the wrong answer. All right, we pretty much are done here. Area of Pentagon is 5 times 1/2 base times height. What's the base in this little triangle? It's x. And the height is h. And for both of these, we found the value. X we previously found was 1.4501 up there. And H we just found was 0.9979, like that. Do the math and you'll get 3.617. 3.617 is the area of this pentagon. And let's see, what is it closest to? 3.617 is closest to choice A, 3.62. Three faces of a rectangular box meet at a corner of the box. The centers of these faces form the vertices of a triangle having side lengths 4, 5, and 6. The volume of the box in centimeters squared is. So first thing, let's draw a box. And now I'm going to draw the centers of the faces. So those three dots represent the centers of three faces. And we now have to connect them to form a triangle, like that. And they're telling us that this triangle has side lengths of 4, 5, and 6. So we'll make this one 4, we'll make this one 5, and we'll make this one 6 in terms of its side lengths. Now, we have to sort of visualize this as not just a triangle, but sort of a pyramid. So I'll do this one step at a time. First, I drew those blue lines to create another triangle. And I want you to pay attention to what I'm about to do. This is going to be the width, this will be the length, and this will be the height. Now, this orange part right here is 4, so we'll leave that alone. But I want you to figure out what is this part here in terms of width. Take a moment and you will realize that is basically W over 2. Okay? And I want you to then figure out what is this distance of that triangle in terms of length. It's L over 2. Correct? Because these vertices, this one, and this one, were basically at the centers of the faces. So if you're going to take those lengths, they would basically be the lengths divided by half. So to avoid confusion, I will draw that triangle again, but I'll draw it on the side. So that is basically our triangle, but if you were looking at it sort of like a bird's eye view, that's a right angle. This is L over 2, and this is W over 2, and the hypotenuse is 4. All right, it takes a little bit of visualization here. So we're done with the first one. Now in a very similar way, let's move on to the next one. Now I drew a red line to make another triangle, and I want you to figure out what are the sides. Well, this side we know is 5, that's already there. But what about this side? We already actually figured that side out, so you should know that's W over 2. Now what about this one in red? What is that? In terms of, I'll give you a hint in terms of H. It's H over 2. So I will draw that triangle on the side, and I will label it. Again, I've drawn it away so that you're looking at it head on. This is W over 2, this is H over 2, and this is 5, the hypotenuse. All right, so by now, hopefully you're getting the hang of it. We've got one more triangle that involves the 6 that we have to now create. And that triangle, interestingly, is already created for us. It's right here. 6, that, and that. So you take a moment and figure out what are the side lengths. I'll draw that triangle right here. Well, the hypotenuse you should be able to figure out without any problem is 6. And then what about this side right here, the base right there? That is L over 2. And then therefore the height right here is h over 2. All right, so there you go. We have carefully created the 3 triangles, and those 3 triangles will basically help us figure out the volume of the box. So here we go. From the first one, we get a relationship L over 2 squared plus W over 2 squared is equal to 4 squared. So that means L squared over 4 plus W squared over 4 is equal to 16. Okay? And then from the second triangle, we get the following relationship. H squared over 4 plus W squared over 4 is equal to 25. And from the third one, we get H squared over 4 plus L squared over 4 is equal to 36. So those are our 3 equations that we got directly from Pythagoras. And each of these, we can simplify these a little bit, multiplying through by 4, and makes it without fractions, and that's perfectly fine. So if you're going to multiply through by 4, this would become 64, and this one would become 8 squared plus W squared is 100, and this one would become 8 squared plus L squared is equal to 144, just like that. And at this point, you've got 3 equations and 3 variables, so you can solve. And there's various ways of doing this. Whatever method that you're comfortable with is perfectly fine as long as you get the right answer. So let's see what I can do. I will just use one of these and substitute the other 2 into it. So for example, from this equation, I can isolate for L squared, and I get 64 minus W squared. And then in this equation, I can isolate for H squared. I'll get 100 minus W squared. And then I can substitute both of those into this guy right here. So I've got 8 squared plus L squared is equal to 144. 8 squared is 100 minus W squared. And then L squared is 64 minus W squared, like that. So I've got 100 plus 64 minus 144 is equal to 2W squared. So this looks like 20 is equal to 2W squared, and therefore W squared is equal to 10, so W is equal to the root of 10. All right. I can substitute that back into these guys and figure out L and H. L squared is equal to 64 minus W squared. So that's 64 minus 10, which is 54. So therefore L is equal to the root of 54. All right. And then finally, H squared is equal to 100 minus W squared. That's 100 minus 10, and therefore 90 is H squared, and therefore H is equal to the square root of 90. And our final step, we have to figure out the volume of the box, which is length times width times height. So volume of the box is length times width times height, like that. Length is root 54. Width is root 10, right here. Height is root 90. And then if you do this, you got a lot of ways of doing this actually. This looks like, let's see here, 9 times 6 under the root sign, root 10, 9 times 10 under the root sign. And then this looks like 3 root 6, root 10, 3 root 10. So that becomes 9. And let's see, the root 10s actually multiply to become 10. And then you've got this lone root 6. So 90 root 6, simplified, is the volume. And let's see if that's one of the answer choices. 90 root 6 is choice C. When the expression that is here is expanded and simplified. The coefficient of x to the power of 2003 is. Before I get started with this question, I'd like to give a little bit of a primer and teach you a system known as ternary. And this ternary system, I hope, will help you solve this question. So, what is the ternary system? It's basically a way of writing numbers, but only using 0, 1, and 2. No other digits are allowed. And you say, well, how is that possible? What if I want to write, 21? Do I write 21 like this? But no, that's not how it works. So let me explain. I'll give you an example. Let's say I wanted to write 21 in the ternary system. Well, what you do is you have to look at it from the standpoint of that each number represents a power of 3. So this number will be equivalent to 3 to the power of 0. The next number is equivalent to 3 to the power of 1. The next number is equivalent to 3 to the power of 2. The next number is equal to 3 to the power of 3, and so on. Now, what is 3 to the power of 0? It's 1. 3 to the power of 1 is 3. 3 to the power of 2 is 9. 3 to the power of 3 is 27, and so on, right? It just kind of keeps on going like that. So if I want to write 21 in ternary, what do? I am only allowed to put a 0 or a 1 or a 2 in each of these slots. If I put a 0, that means I do not count that. All right? If I put a 1, I do count it. If I put a 2, it means I count it, but I have to multiply by 2. So, for example, if I put 2, 1, and 0, what does this equal? It equals 2 times 9 plus 1 times 3 plus 0 times 1. This is equal to 18 plus 3 plus 0, and that is indeed 21. So I wrote 21 in ternary in the following way, 210. All right, so does that make sense? I hope. I know if you're new to this, it might be a little confusing. So let's try to write 2003 in ternary, that big number. So since we're doing this for the first time, let's write out our powers. We got 3 to the power of 0, 3 to the power of 1, 3 to the power of 2, and so on. And I'll write these out and I'll come back. So 3 to the power of 0 is just 1. And this is 3. This is 9, 27, 81, 243, 729, and so on, 2187. Okay? Now I want to write 2003 in ternary. Takes a little bit of practice, but you know that you obviously are not going to include this guy because that is already bigger than 2003. But I most likely will need to include this one. So I'm going to include it twice. And then the way it works is that you will include this, but twice. 0 for this guy, 2 for this guy, 0, 1, and 2. So this basically becomes 2 times 3 to the power of 6 plus 2 times 3 to the power of 5 plus, you don't count this one because it's 0. So 2 times 3 to the power of 3, don't count the next one, but 1 times 3 to the power of 1 plus 2 times 3 to the power of 0. Okay? So this is 2 times 729 plus 2 times 243 plus 2 times 27 plus 1 times 3, and plus 2 times 1. This is 1458 plus 486 plus 54 plus 3 plus 2. And if you add that up, it is 2003. So how do you write ternary in 2003? Like this. Okay, so I hope that makes sense. That's a little bit of a primer before we start the question. So now let's begin the question. So they've got this big long expression. They want you to find, after you've expanded it and simplified, what is the coefficient in front of x to the power of 2003. Okay, now I hope you can see, if you look at this carefully, that each of these is sort of similar, right? There's a little bit of a pattern there. And that pattern leads me to this conclusion that each term is basically of the form 1 plus 2 to the power of n times x to the power of 3 to the n for the following n's: 0, 1, 2, 3, 4, 5, and 6. So for each of these values of n, if you plug it in to that, you'll get one of these terms. So this squared here, don't forget about that one. It's squaring the entire term, and that's why the entire term is in this big bracket at the end there. So that basically means that when you were to simplify these, this will become squared, that will become squared, like that. Like that. And then, of course, we don't need to look at that one anymore. See what I mean? So let's do that. Let's take each term. We already concluded that each term is of that form. And let's square it. So we've got 1 plus 2 to the power of n times x 3 to the power of n, and we're going to square it. If we do, we get 1 plus 2 times 2n x 3 to the power of n plus 2n squared x 3 to the power of n squared. Okay? If you simplify this, you get 1 plus 2n plus 1 x to the 3 to the power of n plus 2 to the power of 2n times x times 2 to the power of 3 to the n, like that. 1 plus 2 to the power of n plus 1 times x to the power of 3 to the n plus 2 to the power of 2n times x times 2 times 3 to the power of n. Okay? Each term, when expanded, is going to look like this. Now, do you see anything that reminds you of ternary? I'll write that term here just to remind you. Do you see anything? I hope so, because this is ternary. 3 to the power of n. That's how we found numbers in ternary. Remember? 3 to the power of 0, 3 to the power of 1, 3 to the power of 2, 3 to the power of 3. Right? Right here. That's all ternary. So that means that we are going to find the coefficient of x to the 2003 using the ternary system. First, what we have to do is we have to take x to the power of 2003 and break it up into the ternary system. And what I'm referring to is the number 2003. And we kind of already did that, so we'll do it once more. And then we have to pay very close attention to the coefficients, because in the end we have to figure out what is the coefficient in front of x to the power of 2003. So before I begin with 2003, I want to practice a little bit here. Okay? So let's do some practice. So let's say I've got a term very similar. I've got 1 plus x 1 plus 2x to the power of 3, and 1 plus 4x to the power of 9. I'm making a small one to kind of give you an example. And in a very similar way, we're going to square it. And I say, find me the coefficient of x to the 13. All right, well, how do we do this? Since this is relatively small, I will first show you how to do it the long way. That one, of course, would become 1 plus x squared, 1 plus 2x to the third squared, and 1 plus 4x to the ninth squared, like that. And if you expand these, you will get very quickly 2x plus x squared, 1 plus 4x to the power of 3 plus 4x to the power of 6, and this one will give 1 plus 8x to the ninth plus 16x to the power of 18. Now, we want x to the power of 13, the coefficient, right? So how do we get that? Well, whatever we are going to multiply will have a coefficient and it will have a exponent from each of these. And when that is completed, it will give us x to the power of 13, and that will have a coefficient, correct? So how do we approach this? Where do we go from here? Well, that's where our ternary system comes in. We have to convert 13 to ternary. And it is 1, 1, 1. Because remember, what's ternary? 3 to the power of 0, 3 to the power of 1, 3 to the power of 2. 1 would mean it's 1 times 3 to the power of 0. 1 over here would mean 1 times 3 to the power of 1, and 1 here means 3 to the power of 2. And then you add these, and you get 9 plus 3 plus 1, and that is indeed 13. So that means that this is x to the power of this guy right here, 3 squared. This is x to the power of 3 to the 1. This is x to the power of 3 to the 0. And now we want the coefficients, and now is where we practice. Here we go. Be very careful here. This is the heart of the question here. We have 3 to the power of 2, correct? Now, am I going to be looking at this guy, or am I going to be looking at this guy? You tell me. It's just 3 to the power of 2, so I'll be looking at this guy. If there was a 2 in front, I would be looking at this guy here. But there isn't. Later there will be, when I do 2003. But right now, I'm only going to be looking at this guy right here. X 3 to the power of n is our x 3 to the power of 2. So in our case, n is equal to 2. So therefore the coefficient is 2. N is 2, 2 plus 1. See how I got that? Now let's try this guy here. In this case, n is equal to 1. So we have 2, 1 plus 1. Got it? How about this one here? In this case, our n is 0. So our coefficient is 2, 0 plus 1. So what are these coefficients? 2 to the power of 2 plus 1 is 2 to the power of 3, which is 8. 2 to the power of 1 plus 1, that's 2 to the power of 2, which is 4. And 2 to the power of 0 plus 1 is 2 to the power of 1, which is 2. And therefore, it's a multiplication question. So our coefficient is 8 times 4 times 2, which is 64. So you see how that worked there? A little bit of practice always helps. And so now we're going to go for the big one here, 2003. All right, here we go. So the first thing, right, we have to convert 2003 to ternary. And I think we already did that. But no problem, a little bit of practice, again, never hurts. So we had 3 to the power of 0, 3 to the power of 1, 3 to the power of 2, 3 to the power of 3, 3 to the power of 4, 3 to the power of 5, and I think 3 to the power of 6 is about as far as we need to go. So our ternary number would be 2102022, and with a little bit of practice you'll be able to get this quickly like I am doing. But let's verify just in case you're not convinced. It also helps us understand what is ternary. Basically, 2003 written in ternary is this number right here, 2202012. But what does that mean? It means 2 times 3 to the power of 6 plus 2 times 3 to the power of 5 plus 0, so don't include that, plus 2 times 3 to the power of 3 plus 0, don't include that, plus 1 times 3 to the power of 1 plus 2 times 3 to the power of 0, like this. If you do the math, you'll get 3 to the power of 6 is 729. 2 times 3 to the power of 5, which is 243. Plus 2 times 3 to the power of 3, which is 27. Plus 1 times 3, which is just 3. Plus 2 times 1, be careful, that's 2. This was 1458 plus 486 plus 54 plus 3 plus 2. And that does indeed add up to 2003. Okay? Now we get to the heart of the question finally. We have to write out x to the power of 2 times 3 to the 6. Remember, we're using these for a reason. The coefficient x 2 times 3 to the power of 5. Next one, x 2 times 3 to the power of 3. Like that. I had to squeeze it all in there. So I've got everything in ternary here. All of these, when multiplied, these guys here will indeed give me 2003. I've even verified it up here. And now I need to concentrate on the coefficients. So here we go. We need to use our general rule. Remember, our general rule was up here. Right here. This guy right here. So I'm going to bring that down into the bottom. All right, here we go. So our first one is x to the power of 2 times 3 to the 6. Now you tell me, is it this one or is it this one that I'm going to be looking at? Look at my coefficient here. 2n plus 1, 2 to the power of 2n, right? But look at more closely at the way the exponent looks. It's this guy, right? 2 times 3 to the n. So I have to look at this one right here. So n in this case is what? N is 6. And I have to then look at that to figure out the coefficient. The coefficient will be 2 times 2 times 6. Correct? All right, great. Now let's go to the next one. 2 times 3 to the power of 5. Which one am I going to look at? This one or this one? It's this one. Right here. So n in this case is 5, and therefore the coefficient is 2 times 5. Okay? No problem so far. Following? Let's keep going. Now we got this one here. What is n? N is 3. And again, I'm going to be looking at that guy. So we have 2 times 2 times 3. Coefficient is 2 times 3. Now, be careful. This guy here, 1 times 3 to the 1. Which one am I going to look at? This one or this one? This is a little tricky. We got to look at this one here because it's in that form. So this time the coefficient will be like this. N in this case is 1. Therefore, the coefficient will be 2, 1 plus 1. Okay? And finally, we've got 2 times 3 to the power of 0. And we're going to be looking there. N in this case is 0. So therefore our coefficient is 2 to the power of 2 times 0. All right, we've got all our coefficients. So this looks like it's 2 to the power of 12. This is 2 to the power of 10, 2 to the power of 6, 2 to the power of 2, and 2 to the power of 0. And I'll write in all the x's. So we've got x to the power of 1458, x to the power of 486, x to the power of 54, x to the power of 3, and x to the power of 2. When you multiply all of those together, this, all of these, it will be x to the power of 2003. Now we have to multiply the coefficients, so we'll do that. The base, of course, will be 2. We're going to add, of course, the exponents. 12 plus 10 is 22, plus 6, 28, plus 2 is 30, plus 0 is 30. And there you go. That is the coefficient of x to the power of 2003. 2 to the power of 30. And going back to the very beginning, 2 to the power of 30 is choice C for number 24. The set 1, 4, n has the property that when any two distinct elements are chosen and 2, 1, 1, 2 is added to their product, the result is a perfect square. If n is a positive integer, the number of possible values for n is. So let's first understand this question. We've got 1, 4, and n in a set, and we are going to take any two of them and add 2, 1, 1, 2 to their product. So for example, we take 1 and 4, multiply them, so 1 times 4, then add 2, 1, 1, 2, and that becomes a perfect square. So what is 1 times 4 plus 2, 1, 1, 2? It actually is 46 squared. So there you go, that's the first one. Great. But we have to do, there's two more, 1 and n and 4 and n. Take any two elements, multiply them together, add 2, 1, 1, 2, and that's going to be some perfect square. And same thing with 4 and n, 4 times n, add 2, 1, 1, 2, and that will be a perfect square. Okay? And c and b, these numbers, b and c are integers obviously, but it's important to write that down. And also, just from the nature of it, c is greater than b. Okay? So now let's move forward with this. This is the first part. We have to somehow get c and b together in some equation. And I can definitely do that. Let's see here. So c squared is equal to 2, 1, 1, 2 plus 4n. But from this guy, we can get n isolated by itself. N is going to be b squared minus 2, 1, 1, 2. So I'll put that into here. So I get 2, 1, 1, 2 plus 4. N is b squared minus 2, 1, 1, 2. And there you go. I've got c and b in the same equation. I'll simplify this a little bit. C squared is equal to 2, 1, 1, 2 plus 4b squared minus 4 times 2, 1, 1, 2, like that. And let's see here. C squared is equal to 4b squared minus 3 times 2, 1, 1, 2. And therefore I'll put the number on one side, 3 times 2, 1, 1, 2, 4b squared minus c squared. And I think that's about as far as we can go. We can factor this. Perhaps that will help. 2b, 2b, c and c, minus plus. And then this number that we have, 3 times 2, 1, 1, 2. Is there anything unique about it? Does it help us in any way? Well, I don't know at this point, but what I will do is I'll break it up into its prime factors. So 3 is already prime, and then 2, 1, 1, 2, that's divisible by 11. And then that leaves me with 192. So 192 is divisible by 64, I believe. And 64 is 2 to the power of 6. And then you get just 1 out of the 3 like that. Yeah, that's pretty much the prime factor of 2112. So I'll just write it a little bit neater. 2 to the power of 6, 3 to the power of 2, and an 11 like that is 2b minus c and 2b plus c. Okay? Now before we move forward, let's remind ourselves what it is we're trying to find. We're trying to find n, right? The value of n. And n is basically, we isolated it as follows. It's b squared minus 2112. So we have to sort of figure out values for b here. Or values for c, because c is also an equation involving n. If we can figure out the value of b and c, we'll be able to figure out values of n. All right, so just wanted to go back and make that clear. Well, okay, we're getting somewhere here. We have b's and c's, and we've got it into its prime factors. So we've got some choices here. But I don't like the fact that each of these has 2 variables. So I'm going to make them a and b like that. It's going to be easier that way. Okay? So on the side here, I'm going to try my best to get a little bit better of a system. If I'm letting a equal to 2b minus c, and I'm letting b equal to 2b plus c, I can figure out b and c in terms of the big A and big B. And I think that's going to help me in terms of figuring out, are they odd, even, and are they divisible by 2, are they divisible by 4? It's going to give me some clues. So the first thing, I can add these. So that would be a plus b would be 4b. That means b is a plus b over 4. All right? That helps, right? Because that means b is divisible by 4. Okay, that's fine. Let me just get as much information as possible before I summarize it. Now I'm going to take these two guys and I'll subtract them, try to isolate for c. So b minus a would be c minus c like that, and the two b's would cancel. So b minus a would be basically 2c, and therefore c would be b minus a over 2. So that means b minus a is divisible by 2. Okay, so we're getting somewhere here. So first, let me just write this out like that, and then I've substituted a and b. Now, what have I learned from doing this? Well, one thing, before I even turn my attention to this, is that a times b, that's even. How do I know that? Because 2 is one of the factors. So 2 times something is going to be equal to AB. So AB is even. That's the first thing. The next thing I notice is that right here, B minus A divided by 2 is equal to C, right? And C and B are integers. We made that clear in the earlier part of the question. So that means if B minus A over 2 is an integer, both A and B are even. That's the only way that would be an integer. If both B and A are even, B minus A over 2 would be an integer. Otherwise, it would not be. It would be like 0.5 or something. Now, I'm going to turn my attention to this and mention something that I think I briefly mentioned before. A plus B divided by 4 is equal to B. That means B is a integer, which we already know. But that means that A plus B over 4 is an integer, and A and B are both divisible by 4. That's the only way a plus b over 4 could be an integer, which in our case is b. So since a and b are both divisible by 4, I can put for a 4x, and for b I can put 4y. Perfectly fine, since both a and b we know are divisible by 4 according to that equation. So this now becomes 2 to the power of 6, 3 to the power of 2 times 11. 4 times 4 is 16, which is 2 to the power of 4. And then you just get x times y. 2 to the power of 6, 3 to the power of 2 times 11. And the 2 to the power of 4 is you can divide both sides by, which leaves 2 to the power of 2 times 3 to the power of 2 times 11 is x times y. This will help us solve for x and y. We can then solve for b and c, and therefore we will get our values for n. Now remember, n is what we're trying to figure out. And n we had earlier a couple forms right here, right? We had one form where n was b squared minus 2112, and we had 4n plus 2112 is equal to c squared. So we can use either of these. I'll use this one here. It looks simpler. B squared minus 2112. So we had n is equal to b squared minus 2112. Now b, we figured out here, is a plus b, a plus large b over 4, all squared, minus 2112. And then a, we call that 4x, right here. And b we called 4y. So we got 4x plus 4y, all over 4, squared, minus 2112. And then the 4's cancel, so all you're left with is just x plus y squared minus 2112 is equal to n. So now we can finally proceed with the table here. We can put x, y, and n. So here we go. X, y, and n. Using this formula right here and using this formula. So if x times y is equal to 2 squared times 3 squared times 11, well, what is that, by the way? The full number is 396. So what are possibilities? Well, we can have 396 for x and 1 for y. We have 198 and 2. We can have 132 and 3. 99 and 4. We can have 66 and 6. 44 and 9. 36 and 11. 33 and 12. And 22 and 18. These are possibilities where x and y are integers. And then therefore, if you take these values and plug them into this equation, you will get the values for n. And you will get the following values: 1, 5, 5, 497, 37,888, 16113, 8497, 3072, 697, 97, minus 87, and minus 512. But n was positive. N had to be a positive number, so we can't use these guys. So how many did we get? We got 1, 2, 3, 4, 5, 6, 7. 7 values of n that are positive. So going back to the beginning, if n is a positive integer, the number of possible values for n is 7. So therefore, number 25, the answer is B.